So what are the US's political problems? No one wants to store nuclear waste in their own backyard, so to speak. For decades, the DOE has been preparing a permanent nuclear waste repository in Yucca Mountain in Nevada. Nevadans have say in the matter. The site was chosen because the state lacked political clout in Washington at the time. However, President Obama has recently taken the project off the table, perhaps to protect his voters' interests. Professor Richter is a strong proponent of involving locals in the waste storage process.
But the bottom-up method is much better than the top-down, and that's what's happened in Sweden, in Finland, and in France. What can I say except let's behave in a sensible fashion instead of the way that we've behaved. So can you do it? Yes. Is it safe? Yes.
Believe Professor Burton, nuclear power is safe, when properly regulated, of course. The public's fear of radiation poisoning is unreasonable. Even if you live within 50 miles of a nuclear power plant, you'll receive only about 1/100th of a millirem per year. That's 3 millionths of the amount of radiation you're exposed to from natural background sources. A second source of fear is a nuclear meltdown in the fashion of Chernobyl or 3 Mile Island. But 3 Mile Island was not as disastrous as you might think. The meltdown was totally contained, and no one was harmed in the accident. Though Chernobyl was no doubt catastrophic, today there are no reactors that utilize the same design. A repeat of the accident is virtually impossible. Let's look at some other favorable qualities of nuclear power. When someone mentions environmentally friendly energy sources, most people think of your traditional renewables like solar, wind, and geothermal. It turns out that nuclear can be beneficial to the Earth too, as evidenced by this life cycle analysis of nuclear power's carbon footprint. The front end of the nuclear life cycle consists of mining, milling, and enrichment. Mining uranium isn't much different from mining coal. The procedure can leave permanent damage to wildlife in mining areas. Mining demands energy inputs to fuel mining vehicles, but these are small compared to the whole nuclear energy life cycle. After it's crushed, screened, washed, and filtered, uranium ore undergoes a process called milling. In milling, acid and alkali baths leach the uranium out of the ore, producing a yellow radioactive powder called yellow cake. Natural uranium only contains 0.7% U-235. To concentrate it to the 4 or 5% needed in fuel rods, the oxide is converted to uranium hexafluoride and enriched through gaseous diffusion or a centrifuge. In 1 year, your standard 1,000 megawatt reactor requires 200 tons of natural uranium. The bulk of the oxide that emerges from enrichment is UF6 and must be stored away safely. The 15% that is enriched uranium is made into pellets of uranium dioxide, packed in zirconium alloy tubes and parceled together to make fuel rods. The mining, milling, and enrichment processes together emit anywhere from 2 to 77 grams of carbon dioxide per kilowatt hour. Nuclear plant construction involves manufacturing, transportation, and use of materials to construct generators, turbines, control rooms, and cooling towers. The typical plant requires 170,000 tons of concrete, 32,000 tons of steel, about 1,300 tons of copper, and 205,000 tons in other material. The materials in construction generate emissions of 1 to 11.5 grams of carbon dioxide per kilowatt hour. The operation phase of the cycle is comprised of cooling, fueling, and repairing the plant, as well as maintaining backup generators. This emits an estimated 0.1 to 40 grams of carbon dioxide per kilowatt hour. The back end of the fuel cycle is made of fuel processing, interim storage of spent fuel in cooling ponds, and permanent isolation in geological repositories. This sums to 0.4 to 41 grams of carbon dioxide per kilowatt hour. The final decommissioning stage involves dismantling the reactor and reclaiming the uranium mine site by replacing rock coverings, replanting indigenous vegetation, and treating radioactive tailings. This emits 0.01 to 54.5 grams of carbon dioxide per kilowatt hour. The carbon footprint of nuclear power varies for a range of mining options, enrichment techniques, ore qualities, and reactor types. The total emissions for the nuclear life cycle range anywhere from 2.83 to 200 grams of carbon dioxide per kilowatt hour. Many sources tend towards a more conservative estimate of 7 to 22 grams per kilowatt hour. Performing a similar life cycle analysis of other energy sources, one can observe that the amount of carbon dioxide released by nuclear power generation is comparable to that emitted by renewables. Because nuclear power plants demand high initial capital costs but bear low marginal operating costs, nuclear energy competes with alternative generation sources for baseload electricity. In developing countries undergoing quick financial growth and increased demand for electricity, nuclear power can help balance supply and demand among coal and natural gas. The upfront costs of nuclear power include owner's cost for land, the bare plant cost for cooling groundwork, and licensing. Overnight capital costs are higher in nuclear power plants due to the need for special materials, advanced safety features, and backup control infrastructure. The newly designed Westinghouse AP1000 reports overnight capital costs of $1,500 per kilowatt. Fuel costs for a standard reactor add to $40 million every 18 months, averaging to 0.57 cents per kilowatt hour. This involves buying, converting, enriching, storing, and shipping the uranium. Operating and maintenance costs contribute 1.46 cents per kilowatt hour and covers administration, labor, and licensing fees. Finally, decommission costs come out to $300 million per reactor. For a plant with a lifetime of 60 years, this adds to 7.13 cents per kilowatt hour. Different life cycle analyses produce different results, but almost all point out the benefits of nuclear's economy of scale.
In conclusion, the benefits of nuclear power outweigh its potential drawbacks, making increased use of nuclear power the best option for fulfilling the energy needs of America and of the world.